Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 15 to 21, which account for 19 of these marks. AQA Paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 15. ABCD is a trapezium. All four sides are different lengths. AB is parallel to CD and the diagonals intersect at X. For each statement, tick the correct box. So triangles AXB, so AXB, so this triangle here, and CXD, so this triangle here, are similar. This is true because they share this point here, and if we were to move the points A and B down, they would lay inside. They would lay on XD and AC somewhere inside this triangle here because of that parallel line. So that's true. Triangles AXD and BXC are congruent. So AXD, BXC are congruent. Congruent means exactly the same. This is not true because we've been told all four sides are different lengths. So AD is a different length to BC, even though that these two lengths and these two lengths we're not too sure about. So that's not true because all sides are not the same. And if it's congruent, all three sides would be the same, not just the two sides of each triangle. Angle ADB equals angle BDC. ADB, BDC, these two angles. This is not true. There is no rule that would make these angles be equal. And then the last question, area of triangle ABC is the area of triangle ABD. So we would do half times the base times the height for the area of the triangle. They each have AB in common. So what we've got, A, B, C. Let's highlight that to make it a bit clearer. A, B, C and A, B, D. So they've got the same base, AB. They've got the same perpendicular height because X is where the diagonals intersect. So yeah, the areas of those two triangles would be the same. Question 16. Solve the simultaneous equations 2x subtract 5y equals 13, 3x add 4y equals 8. So let's call this equation 1 and equation 2. So I'm going to make the y terms of each equation equal in this instance. So I'm going to multiply equation 1 by 4 because that's the coefficient of y in the other equation. So 2x times 4 is 8x, negative 5y times 4 is negative 20y, and 13 times 4, 13 times 4, 4 times 3 is 12, 4 to 4, 52. Remember to multiply everything in the equation. I'm now going to multiply equation 1 by 5 because that's the coefficient of the y term in the other equation. So 3x times 5 is 15x, positive 4y times 5 is positive 20y, and then 5 times 8 is 40. So now my y terms are the same. They both have a coefficient of 20, but they have different signs. Because the signs are different, I need to add these equations together. By adding these equations together, it's going to eliminate the y term and make it so I can solve for x. So 8x add 15x is 23x. Negative 20y add 20y is going to be 0. 52 add 40 is going to be 92. So now we're going to divide by 23. So we're doing 92 divided by 23. So what we got? 23, 46, 69, 80, 92. 1, 2, 3, 4. So x is equal to 4. Now I know that x is equal to 4. I can substitute this value back into one of my original equations to calculate the y value. I'm going to use the bottom equation because I'm dealing with a positive and I don't have to worry about negatives. So using equation 2, which is 3x add 4y equals 8, I'm going to substitute x equals 4 into the equation. So 3 times 4 add 4y is equal to 8. 3 times 4 is 12. So 12 add 4y is equal to 8. Now we're going to solve this equation for y. So the first thing I'm going to do is subtract 12 from both sides. So we have 4y equals, and then when I subtract 12 from the right hand side, we get negative 4. 8 subtract 12 is negative 4. The last step is to divide by 4. It's the inverse of timesing by 4. So y equals negative 4 divided by 4, which is negative 1. So x equals 4, y equals negative 1. Question 17. A solid hemisphere has radius x. A solid cylinder has radius 3x and height x. The surface area of a sphere is 4 pi r squared, where r is the radius. Work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder. Give your answer in its simplest form. You must show you're working out. Okay, let's deal with the hemisphere first. So surface area is all the way around the outside. So we would have 4 pi r squared divided by 2, because that's the surface area of a sphere, but then we halved it for the hemisphere. That gives us the curved part of the shape, but then we need the flat circle at the base there, which would be add pi times radius squared. We know the radius is x, so we have 4 pi x squared over 2 plus pi x squared. 4 pi x squared over 2 can be simplified to 2 pi x squared, and then 2 pi x squared add pi x squared is 3 pi x squared. So that's the hemisphere. Let's deal with the cylinder now then. So to find the surface area of the cylinder, we need the area of the two circles. So we're going to have 2 pi r squared, because pi r squared is the area of a circle and we've got 2 of them. Then we also need the circumference multiplied by that x length there. Circumference is pi times diameter multiplied by x. So let's stick in what we know here. So r is 3x. So we have 2 pi 3x squared plus the diameter. If the radius is 3x, the diameter is double that, which is 6x. So we have 6x times x, which is 6x squared, and we've got that pi there as well. Let's simplify this a little bit further. So 3x squared. 3 squared is 9, x squared is x squared, plus 6 pi x squared. I've just written that slightly differently because pi is still a number, so we can use it as a total coefficient. Now let's simplify this. 2 times 9 is 18, so this is 18 pi x squared plus 6 pi x squared, which gives me 24 pi x squared in total. So let's write this as a ratio. The total surface area of the hemisphere, 3 pi x squared, to the surface area of the cylinder, 24 pi x squared. We can divide both sides by x squared. We can divide both sides by pi. So we're left with 3 to 24, and they're both multiples of 3. So if we divide by 3, we get 1 to 8, and that's what goes on your answer line. Question 18, we have an inequality here. Circle the possible value of x. So at the moment we've got the cube root of x in the middle. So what I'm going to do is I'm going to cube the inequality to get rid of that cube root. So I'm going to have 6 cubed and then 7 cubed. So 6 cubed, 6 times 6 is 36. 36 times 6 is 216. So it's 216. 7 cubed. 7 times 7 is 49. 49 times 7. 7 times 9. 7 times 4. 343. This may only be a 1 mark question, but don't be afraid of working out. Make sure you get the correct answer. So the value of x is somewhere between 216 and 343, but not equal to either. So it must be 290. Question 19. Work out how many 5-digit odd numbers can be made using these digits once each. We've got 1, 2, 3, 4, 5 digits. So we can't list them, and it would take a while anyway. So here we've got an even, 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 odd, and odd. This is important because we want to make an odd number. So if we want to make an odd number, then that last digit has to be odd. Okay, so we've got digit 1, 2, 3, 4, 5. This must be odd. Okay, if it's not odd, then we haven't got an odd number. So here, we're going to work systematically this way through the number. So there are only 2 options for it being odd. So we're going to put a 2 there. Now we're going to figure out how many options there are for this digit here. Well, it can be even or odd. That's not a problem. But we've already used one odd number. And we've used 1 out of the 5. So there's only 4 numbers remaining. When we go to this one, we've used 2 numbers. So there's only 3 remaining. When we've come to this one, doesn't matter if it's odd or even. We've used 3 numbers. So there's 2 remaining. And then when we get to this final digit, we'll have used 4 of the numbers. So there's 1 remaining. So we need to multiply those numbers together. So 1 times 2 is 2, times 3 is 6, times 4 is 24, times 2 is 48. So there are 48 possible options. Question 20. K, L and M are weights. Both of the scales balance exactly. How many M weights are needed to balance 1 L weight? Okay, so what have we got here? So this scale is balanced, so 3 K weights is equal to 1, 2, 3, 4 L weights. Okay, and then on this scale, 1 K weight is equal to 1 L weight plus 2 M weights. So at the moment, we can't really compare these because we've got K and 3K. So let's multiply this one by 3. So 3K equals 3L plus 6M. So now we can compare them. So this 4L must be equal to 3L plus 6M. So when we subtract 3L, 1L is equal to 6M. How many M weights are needed to balance 1 L weight? Well, the answer is 6. Question 21. Express x squared subtract 6x subtract 15 in the form of x subtract a or squared subtract b, where a and b are integers. So this is completed square form. So we're going to complete the square. So inside the bracket goes half of the coefficient of the x term, this thing here. So half of -6 is -3. Now I'm going to square this value. -3 squared is 9, and then subtract it from the outside of the bracket. I still have to take into account the -15, and then we're going to simplify. So x subtract 3 squared, -9 take away another 15 is -24. And I'm going to pop that on my answer line because it's now written in the form requested. So we've completed the square.